All right. Okay. I guess let's go back then. So probably you guys had a nice lunch break and are ready for this afternoon's sessions. So I guess first of all, welcome to this talk on what you can do with Lambda in 2020. So maybe let's start by letting me define what do I mean when I say serverless. You see, ever since Lambda was released, 2014 during reInvent, serverless became a thing, and I kept playing this game where every time I say serverless, someone reminds me that there's still servers somewhere, which of course is missing the point because I think, and Graphql I think says this best, that serverless is serverless in the same way that Wi-Fi is wireless. Even with Wi-Fi, you still have cables, but when you connect to a Wi-Fi device, you're not thinking about those cables because they're no longer your problem. And the serverless is exactly the same way. And typically when I say serverless, I mean any technology, not just Lambda, whereby you don't have to worry about the scaling, you don't have to worry about the provisioning and managing servers, and hopefully you don't pay for them when you're not using them. So in other words, there's a lot of parallels to something like taking a taxi, whereby before we used to have to own the car, we have to pay for the fuel, we have to do our own navigation, and then with the taxi, we just put our app, get an Uber, and then we just have to focus on getting to where we want to go. And it's the same way with the serverless that before we used to have to manage the physical servers, and we have to manage the operating system, the runtime, and as we evolve from the physical servers to virtual machines, containers, and now with Lambda, we can focus on just on the things that we actually want to run, the code that we want to ship, rather than all the things around them. In this case, with Lambda functions, you write a very simple piece of code that handles some event, giving some context, and you upload to the cloud, and you let AWS handle triggering your function when something happens, which could be a customer hitting a HTTP endpoint, it could be an IoT device sending a message to Iot Core, it could be some of your microservices publishing an event to SNS topic or to drop a file into S3, and then that will trigger your Lambda function to do something. And the nice thing with Lambda is that it's auto-scaled by traffic. So if there's more customer demand on your API, then don't have to worry about scaling. The system auto-scales. And when there's no traffic, when no one's using your application, it also scales down to 0. So you don't have to pay for all those idle servers sitting there and not doing anything. And then the benefit you get out of the box with Lambda is that your functions are deployed to multiple availability zones by default, 3. In fact, if you use serverless components like API Gateway and DynamDB, all of these managed services, they all give you multi-AZ out of the box, and you don't have to worry about doing load balancing yourself because that's all part of what the system gives you. So if a request going to a API Gateway endpoint, then well, that's going to be load balanced within the system. You don't have to worry about that so much. And if you have requirements that goes beyond just having multiple AZ, you have to worry about regional failures, then it's also quite simple for you to say deploy your API Lambda and DynamDB to multiple regions, and then configure DynamDB to be a global table, so that you can put a Route 53 in front of your API endpoints, and then you can route the users to active regions if one of the regions goes down. So you can get the multi-region active fairly simply when you're using purely serverless components. So my name is Yan Cui. I'm a long-time AWS user. I've been using AWS for over 10 years now. And the last couple of years, I have focused primarily on serverless technologies, including migrating a social network to run pretty much entirely on serverless, which you can read about here. Nowadays, I spend half my time working with Lumigo as a developer advocate, and the Lumigo is a troubleshooting platform for service applications. And the other half of my time, I work as an independent consultant, where I work with customers all around the world to help them go faster for less by adopting serverless. I also run a weekly podcast called The Real World Serverless, where I speak with other builders to talk about how they are using serverless technologies to revolutionize their businesses. And I've got an upcoming video course on Appsync and the Graphql, where you're going to build a Twitter clone. So if you're interested, check it out at the appsyncmasterclass.com. So let's go back to what you could do with Lambda in the 2020. Probably the most popular use case we see is building APIs with API Gateway, Lambda, and the DynamoDB. This is like your holy trinity for your serverless applications. You see this all the time. In terms of API Gateway, you actually have two choices here. You can use the REST APIs, but the new, the version 2 of API Gateway is HTTP APIs, whereby it's very much the same model, but per request is looking at a nice 70% saving if you use HTTP APIs instead of REST APIs. That's of course, you can also use ALB as well, which has got a very different cost model. Whereas API Gateway itself charges you based on the number of requests you handle. ALB charges you based on load balancer unit, which is a unit of, how much traffic you're handling, how many connections you have, and so on. And depending on how much traffic you've got, you have to use more load balancer units. And if you look at the pricing, the fact that you're paying for uptime for ALB means that when you don't have a lot of traffic, you probably end up paying more than the API Gateway. So this is a rough estimate based on, say, 1 request per second, and there's some rough amount, 200 milliseconds of average latency. But as you scale your throughput to maybe say 1,000 requests per second, sustains through a whole month, then the API Gateway can be significantly more expensive, even when you consider HTTP APIs itself is quite a lot cheaper compared to REST APIs. ALBs can still be significantly cheaper in this particular case. So one of the things that you kind of learn over time is that on AWS services where you pay by uptime, they tend to be order of magnitude cheaper when it comes to running at a reasonable amount of scale. So ALB, a lot cheaper compared to API Gateway. The same argument can be made about the containers and Lambda, even though you do have to consider the other overheads that's involved with running a containerized environment. And another question I get a lot is, while we're building all these APIs, we worry about the user-facing latency. With Lambda, don't you have to worry about cold starts? The first thing, if you do, yes, you do. The first thing you do is make sure that you try to optimize your Lambda cold start duration, because you can't control the frequency, which is a function of how much users are using your API. So you can't really control that, but you could control with some amount of control, at least how long those cold starts are, by optimizing your code so that you minimize the amount of dependencies you have to load. You minimize the amount of things you have to do in the cold starts. Then hopefully, if you're using languages like Node.js, Python, and Golang, you can get the cold starts well under maybe, say, 500 milliseconds, which is probably good enough for most people's web applications as, say, like a 95th percentile latency. And if you've done everything you can, but you still can't get the cold start latency to what you need, maybe using Java, which got higher cold start time, or maybe .NET Core, which is similar thing, has got the high cold start time, then you can also use the provisioned concurrency as a fallback, whereby essentially you're paying for having a fleet of warm containers that's running your Lambda function all the time, and you're paying for you got a different pricing model compared to the normal Lambda on-demand concurrency. So that's probably the most popular use case with Lambda, building REST APIs. But sometimes we've got to do more than that, right? Sometimes we want to build something that has got a push element to it, where we want to use WebSockets. The funny thing is with WebSockets, you actually have quite a few different options within AWS using just serverless components. You have API Gateway, you've got Appsync, and Iot Core. So starting with API Gateway, the way it works is that you've got a couple of, events that you can handle with Lambda, whereby when someone connects to your WebSockets API, you have an on-connect hook that you can handle with a Lambda function, whereby you're gonna get the connection ID, and then if you want to be able to send it to that connection later, you have to put it somewhere. most likely you're going to put into a DB table. This is also where you're going to do things like, okay, we are implementing a chat group so that we need to know the connection and then which group that the user is in. So you put those two things together and put into like a mapping table. And then when someone disconnects, you have to then remove that connection from your database. And when it comes to time to actually send a message to someone who's in the chat group, what you're going to do is you're going to have a Lambda function, go to DB to say, hey, I want to find people who are in this group and get me all of their connection IDs. And then for each of those IDs, I'm going to send a message to API Gateway to say, please send this new hello world message to this connection ID. Which, of course, as you think about this now, thinking through how this works, it's quite clear that the API Gateway's WebSockets implementation is very low-level construct. You have to manage the connection mapping itself. Hell, you have to remember the connection IDs yourself. And there's no built-in support for broadcasts, whereby, for example, if you want to send messages to everyone in your system, you have to fetch the connection ID from the database every single time, which, as you can imagine, if you've got like 1 million connected users, then that is a lot of DB reads and writes. And it's also a lot of API calls to API Gateway as well, which is just not very efficient, and also probably not going to scale that well when you have to deal with Lambda's 15 minutes invocation the time limit as well. So that's why I think with Appsync, the WebSocket side of things is a much better story compared to API Gateway. So with Appsync is the GraphQL as a service. And last reInvent, they introduced the support for real WebSockets for Appsync subscriptions, which is a mechanism for you to subscribe to some, say, entity in your application, and then you can push updates to anyone who's subscribed to those kind of updates. Before, Appsync was using really Iot Core under the hood, so it wasn't really using native WebSockets. But since last reInvent, they have introduced a native WebSocket support, which has incidentally improved the scalability you get with subscriptions on Appsync, which now this is from the announcement blog post whereby they show that they can do over 10 million concurrent devices, subscribers to to Appsync subscriptions. And the way you set it up is really easy as well. You basically have to configure a subscriptions type in your GraphQL schema, and then you have to connect that individual subscriptions to a mutation, so that anytime you push an update to that mutation, the subscribers would get an update through their subscriptions. So Appsync subscriptions, it's very scalable, very easy to use, but you do have to use GraphQL. So if you decide to use Appsync subscriptions for your WebSocket push mechanism, then you have to work with GraphQL in that case. And the last choice you have is Iot Core, which is not at all for just IoT. It can be used for a lot of other things, and also has support for MQTT over WebSockets protocol as well. The main downside with using Iot Core is that from the connection side of things, you have to sign your request using AWS v4 signature, which normally means that you also have to set up a Cognito identity pool so that the IoT devices or even web applications or mobile applications have to then get some AWS credentials so that they can then connect to Iot Core directly from the client. And also the messages are going to be in MQTT format as well, which is a messaging format, which is quite easy to work with, but still it's something that you have to deal with in your application code. So that's WebSockets. Another common API that we like to build is more and more so now is GraphQL. So we already touched on Appsync, which is the GraphQL as a service, whereby you can design your GraphQL API with your GraphQL schema, and then you upload it to Appsync. And for each of these queries or mutations and maybe types within, or maybe fields within types, you can then connect them to what is called the resolver, so that you can basically tie them to either Lambda function to maybe directly ability to get data from DynamoDB, from Appsync, or from Elasticache, or from RDS as well. So it allows you to build data-driven applications very, very quickly. And the Appsync itself is scalable, including its subscriptions implementations for WebSockets. And also it gives you multi-AZ out of the box, which is again, a benefit you get when you're working with serverless components. And with Appsync, you pay for the operations you actually do when no one's using it. You don't pay for it, and you pay $4 per million operations. So those are queries and mutations. Each one of them counts as one operation. And then it's got the built-in caching enabled, and so when you do want to use the caching from Appsync, you do have to pay extra. You have to essentially pay for uptime for a memcached node, and depending on how much, how much memory you need, you also have to pay maybe slightly extra as well for the memcached nodes. And it's got the built-in monitoring, alerts, and metrics through CloudWatch. And also, it gives you all of this without you having to manage any servers. And this is probably my favorite way for building applications on the AWS nowadays, using Appsync with a combination of DynamoDB and Lambda. So Graphql is another very popular use case, definitely more and more so, as I can see a lot of my clients are now jumping onto Appsync, having previously done a lot of work with API Gateway. But it's not just APIs, right? We build a lot of other things on AWS, including data pipelines, including that feeds maybe our machine learning algorithms, and maybe other, or our BI analytics and so on. So with data pipelines, your most, the most popular implementation you see is using Kinesis as a sync to get all the data into your system and then process them in real time using Lambda. I just spoke about this use case with Anihit from Wally a little while back on my podcast, where they were talking about Wally, who is the national broadcaster for Finland, and they're processing somewhere in the region of 500 million messages per day, and it's all going through Kinesis and through Lambda. And of course, the nice thing with Kinesis is that you can actually have different subscribers. Maybe you have Lambda function to do some real-time transformation of the data, but if you just want to take the data, aggregate them, and put them into S3, you can also connect a file host to the Kinesis data stream to batch and buffer the data into large files, and then put them into S3, so that later on, when you want to analyze them, you can do that with Athena fairly easily, because you can then run the basically SQL queries against all these terabytes and terabytes, or maybe gigabytes, sorry, or exabytes of data you have in S3, and you can still get queries returns very, very quickly. And maybe you want to do some real-time aggregation, say like calculate some total aggregates for a rolling 10-minute window. You can also do that with Kinesis Analytics, so that you don't have to do custom logic to do the aggregation. You can have Kinesis Analytics do that for you by writing something very simple queries, and then you can put out those aggregates to a Lambda function to do other transformation and push them somewhere else. Or maybe you just want to collect them and put them into S3 or Elasticsearch. Then again, you can output them to a file host data stream. So or putting it out into another Kinesis stream, and then you can, the whole thing can happen again, where you have Lambda, file host, and so on. So using the sort of suite of tools you get from Kinesis is very, very popular for building big data applications in the AWS, and we see a lot of people using this combination in those sort of machine learning and business intelligence kind of workloads. But then what happens if you're not actually building the application itself, but you're more focusing on the automation, the DevOps side of things? There's also a lot of things with Lambda that you can do here as well. For example, if you got all these cron jobs where you have to run a server 24/7 just to run some cron job every hour, you can now take a lot of that code and then put them into Lambda and then have a cron expression you configure in EventBridge that will run your cron job and trigger your Lambda function based on your schedule. But you can also be very event driven as well. So for example, maybe you want to do something every time someone, I don't know, terminates an EC2 instance, or maybe every time someone deploys an update to your API, or maybe every time someone creates a new log group because they've deployed a Lambda function and you want to run some code. So for that, you can create an EventBridge rule whereby you can match any number of events that are being published to EventBridge, but also anything that's captured by CloudTrail. So in this case, you can use CloudTrail as your sync for every API call or any sort of config changes that's happening in your AWS environment. And then you create EventBridge rule to match against the events that you're interested in, and then have that trigger a Lambda function every time when that happens. It could be a case of you want to do some automation around cleaning up EBS volumes and other things that tend to get left behind when someone terminates an EC2 instance, or just automate a lot of things you do around your AWS environment. And in terms of governance, you can also use Lambda with AWS config, which records config changes to your AWS resources. And you can also perform, I guess, the validation to make sure that how you configure your resources is following your the rules that you have in your organization. You can implement the custom rules using Lambda function to be used with AWS config, and you can also do automatic remediation for non-compliant configurations using Lambda and AWS config as well, whereby AWS config is going to emit an event to EventBridge that can be captured and matched in EventBridge when you find a resource whose configuration violates your organization rules. Maybe you've got a Lambda function that's got IAM roles, permissions, that's got a star in the DB actions or something like that. And then you can apply automatic remediation through a Lambda function in this case to then change configuration to something that matches your organization requirements. So in terms of a lot of the sort of DevOps and Dev security ops or DevSecOps automation people are doing, you can automate a lot of those with Lambda nowadays. So far we talked about, I guess, individual parts into your APIs and so on, your data pipelines, but then sometimes we have more complex business flows that requires maybe human interaction, maybe someone have to answer an email, click a link in the email and things like that, whereby we want to model those business flows. This is where something like Step Functions comes in, which is an orchestration service that allows you to model those business workflows as state machines using this JSON-based syntax. But depending on what framework you use with your Lambda functions, you may also be able to do this using the serverless framework or with SAM, which allows you to do that, design your state machines in YAML as well. But ultimately, you're designing, you're modeling your workflow in this state machine, whereby you have lots of what is called the different steps, these states. Those states can do different things. Most likely, they're going to be doing some action, and you can have that action be performed by a Lambda function. So in this case, one of the benefits of using Step Functions is that you get this visualization tool for when you're designing the workflow, but also when it's executed. When someone executes the workflow, depending on the design of the workflow, there may be logical branches, if else, and you may have some parallelism happening as well. But you can see for individual execution what was the path that you actually went through. And for many of these states, you're most likely going to be doing something using Lambda to perform some business logic, maybe to talk to PayPal to process some payment, or to talk to some other services, or to do some data transformation. And then the nice thing you get out of the box with Step Functions is that you collect all the execution history for that state machine execution. So if you're using Lambda function to perform task, then you can also have a shortcut to the Lambda function itself, but also to its logs as well, so that you can see, okay, what additional things that do we log as part of this execution for step functions. One thing I do find annoying is that that link takes you to the logs for the CloudWatch logs log group for that function, but you still have to find the log stream yourself. And so I really hope AWS will fix this, and so it takes me to the correct part of the log stream, and then show me just the logs I want to see, rather than forcing me to have to actually look for it myself. So the way step functions charges you is also based on usage by the number of state transitions, which incidentally actually includes the start and end states as well, which is something that I found out only when I start looking at the AWS billing, and it's something that's it's not clear on the pricing page for step functions. And at $25 per million state transitions, this is one of the most expensive services on AWS. It's order of magnitude more expensive than the Lambda functions that you're going to use in your state machine. Which is why at the last re:Invent, they also announced a variant of the standard workflows you find in step functions called Express Workflows, which is designed for short-lived workflows, which can then, Express Workflows are only limited to 5 minutes, whereas the standard workflows can run for a whole year. But they are significantly cheaper. They are charged based on duration and the memory use, and it's roughly the same as your Lambda functions pricing. And they're also much higher throughput, whereas you have a limit of, I think, about the 5,000 state transitions per minute, per second on the standard workflows as a default. You can raise that as with a support ticket. With Express Workflows, these things can go up to hundreds of thousands transitions per second. So it's designed for those high throughput but short running workflows. There's lots of companies already. They are using step functions for all kinds of different all kind of use cases, from iRobot, Thomson Reuters for video processing, and to other companies that are using it for managing a lot of their payment processing and other similar workflows. So if you want to learn about step functions, I've got a video course. You can feel free to check it out afterwards, called The Complete Guide to AWS Step Functions. And that's how you can model business workflows using serverless technologies and Lambda functions. And one of the, I guess, the oldest use case for Lambda is to actually encode videos and images. So S3 was the first trigger for Lambda, whereby you drop a file into S3 bucket, and then you can trigger a Lambda function to do some processing. In this case, if you're going to be encoding videos, you can trigger elemental media convert, and then media convert is going to convert that to the right format and the encoding and all that, and then spit it out into another S3 bucket. The main downside to using elemental media convert is that typically a 5-minute video is going to take 5 minutes to actually encode. And so even though it's a fully managed services, which is great, but sometimes you just need it to be done a bit faster. So one thing that a lot of people do now, at least I've seen more and more people do, including Thomson Reuters, is to use something like step functions to help make this a bit faster by using first step functions to trigger a Lambda function to split the video into many smaller fragments using FFmpeg. And with the step functions, you now have a map state, which allows you to do a dynamic parallelism, so that based on the number of fragments that you've created, you can then create, say, 10 parallel executions, again, using Lambda functions to then process those individual fragments, again, using FFmpeg. And then they all going to spit out some output. Maybe the files are going to be too big, so they're going to put it onto S3. So each parallel execution is going to spit out the path to the S3 file for the fragment. And one of the nice things you get with the map state is that it will collect all the results for you. And then put them into and collect them into like an array where the indices match the input array. And in this case, you have all the fragments for the videos that has been encoded. And then you can trigger a next step, again, using Lambda function and FFmpeg to stitch all the fragments together again and spit out the actual encoded video into S3. This is pretty much what Thomson Reuters does, except that they were doing this before the map state, and they were using the parallel state so that they had, I think, a fixed parallelism of 10, so that they can increase the processing time of those videos by 10-fold. And now using the map state, they can go much even further than that, and they can be more dynamic in terms of the amount of parallelism they use. So that's video encoding. Just quickly running through some of the last ones. You've probably been hearing event-driven architectures quite a bit. It's kind of inherent to the way the Lambda works, but you can also take that into how you design your own application as well, whereby you're going to need to use some event bus to capture all these events that's happening in your microservices everywhere. And nowadays, you should prefer to use Event Bridge over SNS for this, for a couple of reasons. One of the reasons is that Event Bridges has got a lot more targets compared to SNS, which has got a limited number of targets. With Event Bridge, you can forward those events to many different places. But also importantly, when you're building an event-driven architecture, it's nice to have a schema for all the different events that's available. So Event Bridge can do this by either automatically discover the schema for the events that's in the bus, or you can create a custom registry whereby maybe as part of your CI/CD pipeline, you will capture all the contracts you have, and then you publish it to EventBridge so that someone can always just look at EventBridge's event registry and then see all the different events you have in your system. And then the thing that really enables having a centralized event bus for all of your microservices is that you can do content-based filtering, whereas with SNS, you can only do attribute-based filtering, and you're limited to, I think, 5 or 10 attributes per SNS message as well. So being able to do content-based filtering really opens up a lot more use cases and make it a lot more easy for you to subscribe to different subset of messages that you're interested in. And the Event Bridge can also connect you with other third-party systems like PagerDuty, Salesforce, and so on. So they can basically handle a lot of the ingestion of those events rather than you have to write bespoke webhooks all the time. And then you can subscribe, and also you can collect events from AWS services, like we saw earlier, through CloudTrail or just other natively supported events, or your own application. And then you can use that to trigger Lambda function to do stuff. And maybe your function is doing something interesting. Then you can also publish those events back into the bus so that other microservices can do their own thing as well. And one common question is, well, in this really heavily event-driven system, how do I handle failures? I mean, there's the delta queue that you can configure for Lambda functions, which is going to give you the payload that couldn't be processed after the built-in retries. But well, the problem with this is that, okay, when something happens, I want to know why it didn't work in the first place, and I have to go to the logs myself to then find out what the error was. And nowadays, you have the Lambda Destinations, which is something you should use instead of DLQs as much as you can. Partly because it supports more targets. You can also automate a lot of the failure handling with Lambda functions if you want to, not just have to put them into SNS or SQS first, but also importantly, the payload it captures includes the request context, the payload itself, but also some context around the request, including how many retries it had, but also, most importantly, it captures the failure context, like in this case, specifically the stack trace, so that by looking at the payload, I know what the payload was, also why it failed, or at least the stack trace for the last failure, so that I don't have to go into the logs to figure out why did my function fail after a couple of retries on this particular payload. But if you're going to use either DLQs or Lambda Destinations, then make sure that you have alerts for those relevant metrics so that you know when Lambda is not able to forward those failed events to your destination or your DLQ. Another thing the Lambda Destination supports that the DLQ doesn't is it supports stream-based invocations as well. So for Kinesis and DB stream functions, this also work the same way. And like I mentioned, you should be using Lambda Destinations instead of DLQs, but you can use them side by side, even though for failure handling, not sure why you would. With Lambda Destinations, you also support on success as well. So if your event bridge function finishes successfully, you can also use that to trigger other functions in the chain. So for this one-hop workflows, this is fine. But if you've got something more complex, then I think you should still be using step functions to model that workflow rather than through lots of on success Lambda function invocations chained together through destinations. So that's event bridge and sorry, that's event-driven architectures. The last two use cases, not something that I can talk about too much because I don't really know them very well. But again, you've got Alexa sitting in your home probably, and you can write the Alexa skills using Lambda functions. And maybe you've got some IoT devices like iRobot robots in your home as well. Then you can also work with those with Iot Core and the Lambda function to do a lot of the automation around your robots. So that's the last case for IoT devices. So those are 10 of the most common use cases we see with Lambda. The last one I want to talk about quickly is just well, that's great, and the serverless is amazing, but when is it not the right choice? I think the first thing you got to consider is what are your non-functional requirements, such as the throughput and the performance, and then to see whether or not Lambda can meet those requirements around performance and scalability, because well, Lambda is very scalable out of the box, but there are some limits. With Lambda, you have the initial burst limit that you can go from 0 to 3,000 containers straight away. But if you have very spiky traffic, like for example, my last company, we do sports streaming. At peak, we see 1.2 million concurrent viewers, and they're all coming at the same time. So you have a very spiky traffic that even if you can go from 0 to 3,000 concurrency, that's still not good enough. And after that, you are hit by a hard limit around Lambda, whereby you can only create the 500 more containers per minute, and which for our use case wasn't enough. There's also other cases where maybe you're building an ultra low latency application where you can't tolerate the occasional cold starts and adding some latency to your application, like trading systems, for example. Then again, maybe those are cases that the Lambda is just not a good fit for right now. However, there are also cases where, okay, maybe Lambda is just more expensive. And this could be the case if you've got an API that's got fairly high throughput, in which case you will have to think about, okay, that's great, but let's think about what is the total cost of ownership, not just how much does it cost to run, say, 5 containers versus Lambda, because a lot of the cost for companies is around the engineers, the brains they have in the company, not just what they pay AWS. So in this case, you have to look at, okay, if I need to run containers, how much more expertise do I need to have, and how much work does that add to my engineers versus using something like API Gateway and Lambda. And AWS actually did some analysis a while back in terms of the impact using serverless has on large IT organizations, and they found significant savings for most companies when they go to serverless, not just in terms of the AWS bill, but most significantly around the staffing cost, because they need few engineers to get as much things done, and also engineers spend less time on infrastructure, and they can spend more of their time, which is very, very variable and also very valuable and very and very scarce resource as well. So they can spend much more of those important resources on things that are actually important to the business. But sometimes that infrastructure cost is just way more significant than your staffing cost, in which case, well, great, start with serverless until it doesn't fit anymore, then move things back into containers. And that's why most of us, we we don't operate with a serverless only mindset. We operate with a serverless first mindset. So we go serverless first until we can't. Then we move things into containers where we pay the penalty of having to maintain more and manage more infrastructure ourselves, where it's worth it. And with that, thank you guys so much for your time and listening to me this morning or this afternoon, depending on where you are. As I mentioned before, I'm an independent consultant. So if you want to see how serverless can help you go faster in your organization, then go to theburningmonk.com to see how we may work together. And if you're interested in learning about GraphQL and Appsync, then check out my upcoming video course at appsyncmasterclass.com. With that, thank you so much. I guess we still have some time. If you guys have any questions, I'm happy to answer them. If not, then thank you and enjoy the rest of the event. Okay, so I guess no questions. In that case, thank you guys. Take care and enjoy the rest of the event.